My dear students, good morning to all. Today we are going to learn about preparation methods and the properties of sulfur dioxide. Okay, so sulfur dioxide chemical formula is SO2. This is one of the simple oxide of sulfur. Okay. Next, sulfur dioxide plays very important role in our regular life. Why? What is the reason? This molecule is used to make sulfuric acid. Okay. Sulfuric acid is used to make so many chemical compounds. Sulfuric acid is one of the important chemical in different chemical industries. Sulfuric acid is used to make different fertilizers and pesticides. Sulfuric acid is used to make different types of medicines. So sulfuric acid is one of the important chemical in our regular life. That is the importance of sulfuric acid. Sulfur dioxide is used to make sulfuric acid. That is the importance of sulfuric acid. And next one, sulfur dioxide is used anti-clog. Sulfur dioxide is used reducing agent. Means sulfur dioxide is a mild reducing agent in acidic medium. Sulfur dioxide is a strong reducing agent in basic medium. Okay, so that are the some of the uses of sulfur dioxide. Next, I am going to discuss preparation methods of sulfur dioxide. Okay. First one, simple preparation method for sulfur dioxide. Amorphous sulfur, sulfur exhibits different types of allotropic forms. That allotropic form of sulfur is converted to amorphous state. That amorphous sulfur reacts with oxygen or oxidation of amorphous sulfur. So the amorphous sulfur is converted to sulfur dioxide gas. The sulfur is a solid state, means amorphous sulfur. Amorphous sulfur reacts with oxygen to produce sulfur dioxide gas. Means the oxidation of amorphous sulfur to produce sulfur dioxide gas. This is one of the important preparation method and a simple preparation method for formation of sulfur dioxide. Okay. And next, second preparation method, sulfur dioxide is prepared from sulfide ores. For example, iron sulfide. This is iron sulfide. Iron sulfides react with oxygen. Means the oxidation of iron sulfide. The iron sulfide is converted to hematite, means Fe2O3, hematite, and a few amount of sulfur dioxide gaseous molecules are eliminated. Okay, an oxidation of iron sulfide to produce hematite and a sulfur dioxide gas. Finally, iron sulfide react with oxygen in the ratio of 4:11. These two molecules are react with one another to produce hematite. This is iron ore, hematite, and sulfur dioxide gaseous molecules are eliminated. Okay. Finally, iron sulfide react with oxygen in the ratio of 4:11. These two molecules are converted to hematite and sulfur dioxide gaseous molecules are eliminated. And next one, sulfite ions. This is sulfide, iron sulfide. This is a sulfide. The above reaction is iron sulfide, iron sulfide. This is sulfite ion. SO3 minus 2 ion is known as sulfite ion. FeS2 is known as iron sulfide. This ion is known as sulfite ion. Sulfite ion react with acid. React with acid. H plus ions are indicated as acid. H plus ions are denoted as acid. Sulfite ion. Okay. Sulfite ion react with acid. It is converted to sulfur dioxide gas and water molecules are eliminated. Sulfite ion react with acid. Acid is indicated as H plus ion. Sulfite ions react with sulfuric acid in the ratio of 1:1 to produce sulfur dioxide gas and water molecules. Or simply, sulfite ion react with acid to produce sulfur dioxide gas and a few amount of water molecules are eliminated. Okay. This is a preparation method for sulfur dioxide. Okay. These three methods are preparation methods of sulfur dioxide. Once again repeated in these three preparation methods. First one, sulfur, simply sulfur and oxidation to produce sulfur dioxide. And the second method is iron sulfide react with oxygen in the ratio of 4:11. It is converted to hematite and a few amount of sulfur dioxide gaseous molecules are eliminated. In this method, like second method is observed. This method is produced large quantity of sulfur dioxide gas than compared to others. This method is used to prepare large quantity of sulfur dioxide gas than compared to others. That is the importance in this method. And the third one is sulfite ions. Sulfite ion means SO3 minus 2 ion react with acid to produce sulfur dioxide. And eliminated few amount of water molecules. Okay, these are the preparation methods of sulfur dioxide. Central in this molecule like SO2, central atom is sulfur. Sulfur bind with two oxygen atoms. Sulfur bind with two oxygen atoms. Generally, sulfur is sixth group element. This element contains 6 valency electrons. 4 electrons are participated for the formation of oxygen bonds, and the remaining 2 electrons are involved for the formation of lone pair electron. In this structure, central atom contains one lone pair electron. In the presence of lone pair electron, these oxygen atoms exhibit some bent shape. Means generally the sulfur dioxide shape is linear shape. In the presence of lone pair electron, this molecule shape is converted to some bent shape. Okay, this is the structure of sulfur dioxide. And next one, the sulfur dioxide is a colorless gas. This is a colorless gas. Colorless gas. And this molecule is exhibits some toxic character. This is a toxic gas. Finally, the SO2 gas is colorless and toxic gaseous molecule. Sulfur dioxide gaseous molecule is colorless and toxic gaseous molecule. Okay. Next one, I am going to discuss properties of sulfur dioxide. Properties of sulfur dioxide. Sulfur dioxide react with NaOH. Sulfur dioxide react with NaOH in the ratio of 1:2. It is converted to sodium sulfate, Na2SO4. Sodium sulfate. So, totally 4 oxygen atoms are present in it. In this molecule, 2 oxygen atoms. In this molecule, 2 oxygen atoms. Totally 4 oxygen atoms are there. So, the 4 oxygen atoms are converted to sulfate ion. So, sodium sulfate. And hydrogen gas is liberated at cathode. In this reaction, so the sulfur dioxide react with the sodium hydroxide to produce sodium sulfate. Okay. Next one, sodium sulfate react with water to produce sodium bisulfate. In this molecule, react with water and sulfur dioxide to produce sodium bisulfate, NaHSO4. NaHSO4 means 2 moles of water is involved. Sodium bisulfate. Okay. First one, sulfur dioxide react with sodium hydroxide to produce sodium sulfate, and then react with water and sulfur dioxide. The sodium sulfate is converted to sodium bisulfate. Okay. So next one, sulfur dioxide react with chlorine. Sulfur dioxide react with chlorine to produce SO2Cl2. To produce SO2Cl2. Why? What is the reason? Sulfur dioxide react with chlorine gas to produce adduct products. Why? Chlorine is act as oxidizing agent. This oxidizing agent react with another molecule. Totally, the 2 molecules are converted to adduct product. Why? That point is based on, in this reaction is based on SO2 is act as reducing agent. Reducing agent react with oxidizing agent, it is converted to additive product. Okay. So similarly, acid react with another molecule to produce salt. The point is based on, that reaction is based on, the unknown molecule is known as base. Acid and base both are neutralized to convert products. Similarly, chlorine is oxidizing agent. Oxidizing agent react with another molecule like sulfur dioxide. It is converted to additive products. This point is based on sulfur dioxide is act as best reducing agent. Okay. And next one, sulfur dioxide is act as best reducing agent due to ferric ions are converted to ferrous ions. Ferric ions are converted to ferrous ions. Which type of ions are known as ferric ions? Which type of ions are known as ferric ions? Generally, iron exhibits two types of oxidation states. Iron exhibits two types of oxidation states. One of the oxidation state is +3. Iron exhibits +3 oxidation state. That ion is known as ferric ion. Iron Fe+3. Iron exhibits +3 oxidation state. That ion is known as ferric ion. Ferric ion. Iron exhibits +3 oxidation state. That ion is known as ferric ion. Next one, iron exhibits +2 oxidation state. Iron exhibits +2 oxidation state, that is known as ferrous ion. That is known as ferrous ion. In this reaction, so Fe+3 ions, Fe+3 ions are reacted sulfur dioxide. Fe+3 ions are reacted sulfur dioxide in the presence of water. In the presence of water, the Fe+3 ions are converted to Fe+2 ions. Fe+2 ions. And the sulfur dioxide is converted to sulfate ion. Sulfur dioxide is converted to sulfate ion. This reaction is maintained in acidic medium. H+ is indicated as acid. Totally, the reaction is maintained acidic conditions. Finally, this reaction is observed. SO2 is act as oxidizing agent or reducing agent. This reaction is reduction reaction or oxidation reaction. The starting molecules like iron exhibits +3 oxidation state. This molecule oxidation state is +3. The +3 oxidation state, iron is converted to +2 state. The +3 oxidation state is converted to +2 oxidation state. Means one electron is gained in this process. One electron is gained in this process. One electron is gained in this process. Generally, any reaction to gain some electrons, in any reaction to gain some electrons, that process is known as reduction process. That process is known as reduction process. In any reaction to loses some electrons, that process is known as oxidation process. In this reaction is observed, the Fe plus 3 is converted to Fe plus 2. Finally, to gain one electron in this process. In this process, Fe plus 3 ion is converted to Fe plus 2 ion. Means one electron is gained. That point is based on, this is known as a reduction reaction. This reaction is known as reduction reaction. Okay. And next one, another example is taken. Sulfur dioxide, 5 moles of sulfur dioxide react with 2 moles of MnO4 minus ions, means permanganate ions. Permanganate ions. In the presence of water, the sulfur dioxide molecules are converted to sulfate ions. 5 moles of sulfur dioxide molecules, this is sulfur dioxide molecules are converted to sulfate ions. The sulfur dioxide molecule is converted to sulfate ion, and the permanganate ion is converted to Mn plus 2 ion. And H plus ions are liberated, means the reaction is maintained acidic medium. Okay, the sulfur dioxide molecules are converted to sulfate ion. And permanganate ions are converted to Mn plus 2 ion. In this reaction is oxidation reaction or reduction reaction. So clearly observed, permanganate ion, this ion, central atom manganese oxidation state is MnO4 minus ion. Mn is denoted as X plus 4 oxygen atoms are there. 4 into minus 2 is equal to minus 1. X minus 8 is equal to minus 1. X minus 8 plus 1 is equal to 0. X is equal to 7. Permanganate ion, MnO4 minus ion, central atom manganese, oxidation state is 7. This ion is converted to Mn plus 2 ion. Mn plus 2 ion, central atom manganese, oxidation state is plus 2. Means in this molecule, central atom manganese oxidation state is plus 7. The plus 7 oxidation state is converted to plus 2 oxidation state. In reactants, manganese oxidation state is plus 7. This manganese is converted to plus 2 oxidation state in products. Means totally 5 electrons are gained in this process. 5 electrons are gained in this process. In any reaction, to gain some electrons, that process is known as reduction process. This process is known as reduction process. This is known as reduction process. This point is based on sulfur dioxide is known as best reducing agent. Okay, once again repeated in these reactions like preparation methods and properties of sulfur dioxide. First one, I am going to discuss preparation methods of sulfur dioxide. Simple preparation method: sulfur on oxidation to produce sulfur dioxide. Sulfur means amorphous state sulfur. This amorphous form of sulfur on oxidation to produce sulfur dioxide. This is very simple preparation method. And the next one, industrial preparation method. So why this reaction, this method is known as industrial preparation method? So this method is used to produce large quantity of sulfur dioxide. That point is based on this method is known as industrial preparation method. This method is known as industrial preparation method. Industrial preparation method. Okay. Industrial preparation method. Simply iron sulfide react with oxygen in the ratio of 4:11 to produce hematite, and a large quantity of sulfur dioxide gaseous molecules are eliminated. Okay, this is important preparation method. And next one, very simple, sulfite ions or react with acid to produce sulfur dioxide and eliminated few amount of water molecules. These three methods are important preparation methods for sulfur dioxide. Okay. Next one, some important physical properties of sulfur dioxide with the structure. First, we are going to learn about the structure of sulfur dioxide. Generally, sulfur bind with two oxygen atoms out of lone pair electrons. Except lone pair electrons, the structure is a linear structure. So generally, sulfur is a central atom in this molecule. Sulfur is 6th group element. This atom contains 6 valence electrons. 4 electrons are participated for the formation of oxygen bonds, and remaining 2 electrons are involved for the formation of lone pair. In the presence of lone pair, this molecule is converted some bent shape. Finally, the original SO2 structure is bent structure. This is the structure of sulfur dioxide. And next one, sulfur dioxide is colorless gas and a toxic gaseous molecule. This gaseous molecule exhibits some toxic character. And next one, some important properties, chemical properties of sulfur dioxide. Some important chemical properties of sulfur dioxide. Generally, the sulfur dioxide react with sodium hydroxide to produce sodium sulfate. The sodium sulfate further react with water and sulfur dioxide gas. It is converted to sodium bisulfate. It is converted to sodium bisulfate. Okay. And next one, sulfur dioxide gas react with chlorine to produce SO2Cl2. Means chlorine is oxidizing agent. It's react with unknown molecule like sulfur dioxide to produce a direct product. This point is based on sulfur dioxide is act as best reducing agent. And another two important reactions are observed. Sulfur dioxide react with the ferric ions in the presence of water. The ferric ions are converted to ferrous ions. The ferric ions are converted to ferrous ions. Means iron in left hand side or in reactant molecules, iron is exhibits +3 oxidation state. The plus 3 oxidation state iron react with sulfur dioxide. It is converted to Fe plus 2 oxidation state. It is converted to Fe plus 2 oxidation state. This point is based on this reaction is observed to gain 1 electrons. To gain 1 electron. This point is based on, this is known as a reduction reaction. This is a reduction reaction. This point is based on, this is act as best reducing agent like sulfur dioxide. And finally, one of the important reaction is observed. Sulfur dioxide react with the manganate ion in the presence of water. Sulfur dioxide react with the manganate ion in the presence of water. It is converted to sulfate ion, and the permanganate ion means permanganate ion MnO4 minus ion is converted to Mn plus 2 ion. MnO4 minus ion, central atom manganese, exhibits plus 7 oxidation states. In products, manganese oxidation state is plus 2. In this process, in this reaction, manganese gained 5 electrons. The plus 7 oxidation state is converted to plus 2 oxidation state. In this step, 5 electrons are gained in this ion like manganese. This process is observed. This is known as reduction reaction. This is known as reduction reaction. Okay, these are the some important chemical properties of sulfur dioxide. Okay, so this is a explanation for preparation methods, physical properties, structure, and some important chemical properties of sulfur dioxide. Finally, what are the main uses of sulfur dioxide? What are the main uses of sulfur dioxide? Sulfur dioxide is used to make sulfuric acid. Sulfur dioxide is used to make sulfuric acid. This sulfuric acid is used to make different chemicals. And the sulfuric acid is used to make different fertilizers. The sulfuric acid is used to make different types of pesticides. That is the importance of sulfuric acid. So the sulfur dioxide is used to make sulfuric acid. This is the importance of sulfuric acid. Sulfur dioxide. Sulfur dioxide is used for anti-chlor. Okay, this molecule is used for anti-chlor. And sulfur dioxide is used best reducing agent in different types of chemical reactions. Sulfur dioxide is used best reducing agent in different types of chemical reactions. These are the